we'll establish a little bit of the language that we use when talking about the shape of a distribution for a quantitative variable. So symmetry and skew is a big part of this. And we have a nice symmetric bell-shaped curve here first. And then we can talk about it being skewed if it has a tail extended to the left or right. So think of it this way. Here's a nice bell-shaped curve. And imagine that under every bell curve there are two cats. Here's our cats. Okay, so if we're talking about skew, we want to think of it as grabbing the tail of the cat. So here's the tail of the cat on the left, and if I pull the tail of the cat on the left, and it gives me a little meow, then what I end up with is left skew. So the point here is that the wording we use to describe the skew is the direction of the tail. So if I pull the tail of the cat on the left, then what I end up with is a graph that is skewed to the left. The reason I'm emphasizing this is that it's not immediately obvious that we wouldn't describe skew by where the mass of the distribution is. The mass of the distribution here seems to be on the right, but we call it left skew if the tail goes off to the left. So same idea here with the right. If we pull the tail of the cat on the right, then we end up with a distribution that is skewed to the right. So skew direction is indicated by the tail. Now, symmetry and skew aren't the only things we talk about in shape of a distribution. All three of these have one peak. This has one peak right in the middle. This one has one peak over here to the right. This one has one peak over here to the left. And if these have one peak, we refer to these as what we would call unimodal. The number of modes is the number of peaks. So these are unimodal distributions, but here's an example of a bimodal distribution. This has two distinct peaks, so we would call this bimodal. Now, we want to be pretty particular about what we refer to as a peak. We would not necessarily count it if we had something like this, a bar, and then a shorter bar, and then a taller bar. I wouldn't necessarily call this pattern here bimodal. So this is not necessarily bimodal. A lot of the time, it's just a matter of not having enough data values to get a really smooth curve. We do expect to see a little bit of jumping around in the bar heights. For example, even in this graph, over here it kind of goes down and then up again, but I wouldn't call this trimodal. That looks like just a little bit of random variation in the bar heights. So for us to call it bimodal, we want to see a very clear pattern establishing two peaks. And what I mean by a very clear pattern is that we see a buildup and then dropping back down again, another buildup and then dropping back down again. Any effect that can be erased by just covering up one bar, right? If I just imagine that that one bar had been just a little bit taller, right? If changing one bar is going to make the effect completely go away, then the effect is probably not there, right? So let's get a little bit of quick practice describing the shapes of some histograms. This here looks to be fairly symmetric. It's not perfect, but they never really are, right? So this is fairly symmetric. If you're not sure what direction you would label the skew, that may be a sign that it's pretty symmetric. It also is unimodal. So this is approximately bell-shaped. We could even call this approximately bell-shaped. This is a distribution of height in inches from one of my student surveys from a previous semester. So height tends to follow an approximately symmetric unimodal distribution. It often has just a little bit of right skew because there are some very tall people. And we can see maybe a little bit of evidence that this tail over here extends out just a hair farther than the tail on the left. The next one, miles from campus to home, we can put in a bit of a curve here describing the shape. Again, we do see a little bit of jumping around in here, but it's the kind of effect that if I just took out this one bar, I wouldn't really see that effect anymore. If I just took out this one empty bin, then I wouldn't really see that effect anymore. So I would not call this multimodal at all. I would consider the variation in bar heights to be very typical behavior when you don't have a really, really large sample. And this definitely has right skew, right? This is the tail of the cat on the right that we would pull. So this has got right skew, pretty heavy right skew. And lots of things have right skew. It's really easy for something that can't be negative to have right skew. Miles from campus to home, this is a measure of a distance. It can't go negative, and a lot of people do live pretty close to campus, so we are going to have some values close to 0. The fact that we can't have a left tail over here because of the values not being allowed to go negative causes the distribution to just get cut off at a certain point, and that's what gives us our right skew. So lots and lots of quantitative variables that measure things that can't be negative tend to have right skew. This, I would also call this unimodal. Like I said, the variation from one bar to the next does not, to me, appear to be a gradual building up and a gradual tapering off again. It appears to just be that choppiness that comes from not having a very large data set. Now we have 2 more distributions. Hours of sleep last night. This is from one of my student surveys from a previous semester. And this one is very hard to describe. I threw it in here not because I would expect you to be able to give a really good description of something like this, but just because we've got to have something that doesn't behave perfectly, right? You might call this symmetric because if I draw a very rough shape in here of the envelope of this curve, it does look a little bit symmetric. You might consider this to be multimodal because this does seem to have a few peaks in it, but it's not clear that those peaks are really there like we're talking about. There may be clusters of students who tend to get more than 7 hours of sleep and clusters of students who tend to get less, right? There may be something like that. So we're going to leave this one without description because there are many different descriptions that may apply. This is not the sort of thing you would expect to see on a test. We're just throwing it in here to make sure that we do see a few examples of shapes that really do seem to defy description a bit. Diamond depth. We have a sample of diamonds that we'll look at a few times this semester. And this is a very clear example of what we might call bimodal, right? We have that shape that we were describing where we have a gradual buildup and a gradual tapering off, and then another gradual buildup with a gradual tapering off. So this is definitely not looking like just a little bit of choppiness due to having a small sample. So this is bimodal. Once it's bimodal, we don't necessarily have such a clear idea of what the skew might be, but I would call this right skew just because we have a taller peak here on the left. So I could think of that as representing closer to my center. And then going with the overall idea, it does look like we have more of a right tail than a left tail. But bimodal distributions aren't always easy to define a direction of skew. They can be symmetric without being at all bell-shaped. Another thing I'd like to say about this bimodal distribution that we saw first is what this distribution represents. This is part retrieval times at a warehouse. So we can believe that that would follow a bimodal distribution. It's very likely that some parts are located very close to the counter, and that I could even see this being a trimodal or more, right, depending on the warehouse. So some parts are near the counter and all the clerk has to do is turn around and grab them, and that would be our first mode. And our second mode would come from, so that some parts being near the counter, that refers to this first mode here. And the parts that take a bit longer to get, where this second mode is, these might be in the back, right? And there's all sorts of things that could be going on here. Maybe a manager needs to be retrieved for some of these to get the keys to the vault. Maybe a forklift needs to be used for some parts, right? There's all sorts of things that could be going on to cause these different peaks and valleys in this distribution. Anytime that you have a multimodal distribution, if you stop and think about whether it makes sense that there would be some clustering of the data values, it can help to determine whether that multimodal characteristic really is there.